Hello and good afternoon dear students. Welcome back to the online class, and in today's class we'll start from question number 7. We are in exercise 22a, heights and distance. Okay, so the question says the upper part of a tree broken by a wind makes an angle 45 degree with the ground. So the upper part of the tree is broken. Suppose this is your tree, it has been broken now, the upper part is broken, and then it is now making an angle 45 degree with the ground, and the distance from the root to the point where this touches is 15 meter. What was the height of the tree before it was broken? Okay, so the question basically says, so there is a tower, sorry, there is a tree, let's say this is my tree, and this is the upper part of the tree. This is dotted line is the upper part of the tree. It has now been broken, and then this broken part of the tree is now making an angle 45 degree with the ground. Means this broken part will come out here. Am I clear? This broken part will come out here, and now it is making an angle 45 degree. If I give it as A, B, C, am I clear? What is the actual height of the tree? The actual height of the tree is AB plus AC. This portion actually is the portion of tree only. Because of the wind, it is broken and it makes an angle 45 degree with the ground. So this is my tree and this is my ground. Am I clear? It makes an angle 45 degree. What was the height of the tree? What was the height of the tree before it was broken? So height of the tree is actually AB plus AC, right? This is what we need to find. AB we need to find, AC we need to find. One thing is given to us is that the distance from the root of the tree to the point where the top of the tree touches the ground is 15 meters. So which means from here to here the distance is 15 meters. So this much is given to us, and we are asked to find the actual height of the tree. Okay, so in this right angle triangle, this is my 90 degree. In this right angle triangle, what do we see is this is 45, so therefore this is my perpendicular, this is my base, so I can use tan 45. So tan 45 is turned permanently black. This is my hypotenuse, right? So permanently black, so that is AB by 15, permanently black. Okay, so what is tan 45? Tan 45 is 1, so 1 is equals to AB by 15. So therefore AB, we will be getting 15 meter. So I got the value for AB as 15 meter. I got the value for AB as what? This AB is 15 meter. Now I need to calculate AC also, because the question is asking us what is the actual height of the tree. The actual height of the tree is AB plus this broken part, isn't it? So we need to calculate AC also now. So for AC, which trigonometric ratio will I use? Can I use sine? Some people have. So yes, we can use sine. So let's use sine. Sine 45 degree. Some people means 15, have means AC. What is sine 15? Sorry, what is sine 45? 1 by root 2, 15 by AC. So therefore cross multiply, AC will be 15 root over 2. So yes, we got the value of AB, we got the value of AC. So therefore, can I find the actual height of the tree? Yes, the height of the tree before it was broken is given by AB plus AC. AB is 15 and AC is 15 root 2. 15 we can take common. So 1 plus root over 2, and root 2, we can use the value of root 2 from the square root table which is given at the back. The value for root over 2 is 1.414. 1.414. If you add, this is 2.414, and if you multiply into multiplication, I have done out here multiplication, you will be getting as 36.21. 36.21 meter was the actual height of the tree before it was broken. Okay, so in this way we have to do. So please pause the video and note it down. All right, let's proceed with question number 8 now. Question number 8, read the question. The question says the angle of elevation of the top of an unfinished tower from a point at a distance of 80 meter from the base is 30 degree. So therefore basically this is my whole tower, but till here the construction is done. Right now the construction is only been done till here. So this is your unfinished tower AB. AB is your unfinished tower, and there's a person at this point C. There's one man at this point C who is looking at the top of this unfinished tower. This tower is in the construction is going on. Okay, the tower has been constructed more. Am I clear? So a man is standing out here who is looking at the top of this tower, top of this unfinished tower. Okay, and he noticed that the angle of elevation is how much? 30 degree. He is at a distance of 80 meter. He is at a distance of 80 meter from the foot of the tower. Okay. The question for this is, please understand this question properly. How much higher must the tower be? How much higher must the tower be raised so that the angle of elevation at the same point be 60 degree? How much high the tower should be raised so that the angle of elevation is 60 degrees. So from here only, the person is standing at here only. Okay, he noticed that the angle of elevation is 30 degree. The construction is going on. How much high the tower must be so that the angle of elevation becomes how much? 60 degree is what we need to find. This angle of elevation now will be 60 degree. So there were two right angle triangles we will be getting out here. One is right angle triangle ABC, and then if I give it as D, other right angle triangle will be ADBC. Okay, so this portion we need to find how much higher the tower must be raised so that the angle of elevation changes from 30 to 60 degree. This is what we need to find. Okay boys, so let's do it. First we'll do in this right angle triangle. So which right angle triangle will I take? I will be taking this right angle triangle ABC. Let me draw a line out here. So ABC. So in this right angle triangle ABC, what will I do is, can I use tan 30 degree? Yes, tan 30 degree is ABC in triangle ABC. ABC. Tan 30 is turned permanently black. AB by 80. Now what is tan 30? Tan 30 is 1 by root over 3. So 1 by root 3 is equals to AB by 80. So therefore, if you cross multiply, you will get 80 by AB is equals to 80 by root 3 is equals to AB. So since root 3 is an irrational number, so denominator, let's not keep an irrational number. So can we do rationalization? Obviously yes. So 80 by root 3 into root 3 by root 3, which is equals to AB. So therefore root 3 into root 3 is 3. So therefore you will be getting AB as 80 root 3 divided by 3. So you will be getting this much. Okay, this is the value of AB. AB is how much? 80 root 3 divided by 3. So this is my AB. Let us assume DA be X. So therefore now in which right angle triangle? Now in triangle DBC. Now let's take triangle in triangle DBC. In this triangle, now the angle of elevation changes from 30 to 60 degree. Okay, so therefore tan 60 degree will be turned permanently black in triangle DBC. DBC. So this is my perpendicular. Okay, turn permanently means DB and black means BC. So tan 60 degree is root 3. So root 3 into dB by BC is again 80. So if you cross multiply, you will get 80 root 3 is equals to dB. So therefore we are asked to find what is the height of the, how much high, isn't it? So how much high? Okay, by the way, dB is not this, sorry. Yes, dB we need to find, yes. Okay, so dB will write. So therefore this is 80 root 3 is equals to dB. Now dB means x plus this, x plus this. DB means x plus this. So therefore x plus 80 root 3 divided by 3. Okay, so what we'll do, we'll bring this side. So once I bring this side, what will I get? 80 root 3 minus 80 root 3 divided by 3 is equals to x. So 80 root 3 is my common, so I'll be getting 1 minus 1 by 3, which is equals to x. Simplify it, you'll get 80 root 3 into 1 into 2 by 3, into 2 by 3, which is equals to x. So therefore this is 180, 80 into 2 is 160 by 3 into root 3 is equals to x. I think so. I've done the calculation out here. Yes. Okay. So 160 by 3, if you do, you'll be getting 53.33, and root 3, you know, it is 1.732. So when you calculate, when you multiply these two numbers, you will be getting 92.37 meter, which will be the value of x. So therefore this tower should be raised by 92.37 meter high, so that the angle of elevation changes from 30 to 60 degree. So this value should be how much? 92.37. I hope you're clear with this. Please pause the video and note it down, boys. All right, boys, let's proceed with question number 9. Your question number 9 says, if you read the question, at a particular time when the sun's altitude is 30 degree, at a particular time when the sun's altitude is 30 degree, okay, the length of the shadow of the vertical tower is 45 meters. So if this is my tower, and if your sun is out here, okay, this sun hits this tower, and the shadow of this tower is 45 meter. This sun is making an angle 30 degree. Am I clear with the ground? Okay. The question says find the height of the tower. So we need to find the height of the tower. So AB, let's find AB, boys. So height of the tower. So therefore out here in triangle this, if I use tan 30 degree, turn permanently black. So tan 30 degrees, again 1 by root over 3, right? So 1 by root 3 into 45 is equals to AB. Turn permanently black. 30 degree? Yes, 30 degree. Okay, so tan 30 degree is 1 by root over 3. So again here also I'm getting 45 by root 3. So I want to rationalize it because I don't want to keep the denominator as decimal. Okay, so I'll be getting 45 root 3 divided by root 3 into root 3 is 3, which is equals to AB. So it's now easy. 3 ones are 3 15s are, so therefore it will be 15 into root 3, which is equals to AB. So therefore AB is 15 into 1.732. Please calculate, boys, how much you are getting. 15 into 1.732, that will give the height of the tower. All right, boys, I hope you got the answer as 25.983 meter, which is the height of the tower. Okay, now the part 2, the question says, for the same tower, okay, calculate the height, calculate the length of the shadow of the tower when the sun's altitude is 45 degree. So when the sun's altitude is 45 degree, we need to calculate the length of the shadow. By the way, what did we got the height of the tower? The height of the tower is 25.983 meter. Okay, so now this one I'm clearing and this one also I'm clearing. Okay, the question says now, if the angle of elevation is 45 degree and the height of the tower is this, what will be the shadow, length of the shadow? So which means I can again use tan 45 degrees, turn permanently black. Okay, and what is tan 45? Tan 45 is 1, so hence 1 is equals to the same thing by BC. So therefore what will be BC? BC will be 25.983 meter only. So when the angle of elevation is 45 degree, the length of the shadow is going to be same. Okay, boys, so please pause till here. All right, and now we need to find the length of the shadow when the angle of elevation is 60 degree. When it is 60 degree, we need to find. Okay, now here I give you another method also. Okay, now the angle of elevation is 60 degrees. Second part we are doing, 9 part to second part. This is the first part, and I am doing the second part now when the angle of elevation is 60 degree. 60 degree also you can do the same thing, turn permanently black, but the problem will be out here. You will be getting root over 3 in the denominator. So I'm giving, you can do in that way also. I'm giving alternative method. Okay, see, we know the sum of the angle is has to be 180 degree, 90, 60. So this angle is 30 degree. I hope you're clear with this. This angle is 30 degree, right? So now what I can do is, I can again, you see, if I use tan 60, if I simply use tan 60, if I use this only, what will I get is, I'll be getting turn permanently black, isn't it? So 25,983 divided by BC, and tan 60 degrees root 3, 983 by BC. So therefore BC used to be 25,983 divided by root 3. So root 3, which means I'm getting irrational number in the denominator, which means it is decimal number. Root 3 means 1.732. So you know, to instead of doing this, what I can also do is, I'll find the another angle. This is 90, this is 60, so this becomes 30, right? So instead of tan 60, now I'm going to use tan 30. I can also do this, tan 30 turn permanently black. So turn permanently means BC and black means AB, right? Okay, but it's going to be the same thing again. It's going to be the same thing as with which I can use now. Then instead of tan, some people have curly brown hair. So if I use cos 30, curly brown hair, BC by no down here. No. Some people have turned permanently black. Turn no. I have to stick with that only. Yes, it's not working. All right. Anyways, so let's do it tan 60 only. Okay. So tan 60 turn permanently means 25.983 and divided by BC. So this time again we need to find BC. So therefore tan 60 is root over 3, which is equals to 25.983 divided by BC. So let's calculate BC. Again the same thing, 25.983 divided by under root of 3. So since there is under root of 3 means 1.732. So 25.983, 1.732, 3 decimal places, you can cancel it out. So therefore BC you will be getting 25.983 divided by 1.732. Please calculate, boys. This will give you your answer. Okay, so please pause the video and note down till here. All right, let's move on to the next question. That is question number 10. The question says, two vertical poles are on the either side of the road. A 30-meter long ladder is placed between the two poles. Okay, so I'm giving this as my first pole, pole 1, and I'm giving this as my second pole, pole number 2. So two vertical poles are on the either side of the road. So this AB is my road. Okay, so what they are doing is, there's a road and there are two poles, vertical poles, and a ladder is been placed in between. A ladder is been placed in between like this. This is the ladder placed against pole number 1, and this is the ladder placed against pole number 2. Okay, a 30-meter long ladder, so which means this is your 30 and this is your 30 meter. Okay, 30-meter long ladder is placed between the two poles. Now the main thing, the question says, when the ladder rests against one pole, it makes an angle 32 degree 24 minutes. So when the ladder rests against one pole, it makes an angle 32 degree 24 minutes with the pole. 32 degree 24 minutes with the pole. Read the question once again. When the ladder rests against one pole, it makes angle 32 degree 24 minutes with the pole. So this ladder is resting in this first pole, and this ladder is making angle 32 degree 24 minutes with this pole. Okay. Secondly, when it is turned to rest against another pole, it makes an angle 32 degree 24 minutes with the road. Now when this ladder is placed against another pole, it makes an angle 32 degree 24 minutes with the road. Now this is with the pole and this is with the road. I hope you are clear with this. Okay, with the pole, this is a ladder, it makes an angle 32 degree 24 minutes with the pole, and this time this ladder makes an angle with the road. Okay, full stop. Calculate the width of the road. We need to find the width of this road. So width of the road means AB is what we need to find. We need to find the value of AB. So AB is what we need to find. This road is AB. So AB is AE plus BE is what we need to find. This is angle 90 degree. This angle is 90 degree. So which means I need to find this and I need to find this. Let's see how we can find. Okay, so in which triangle I'll take first? I'll take triangle DAE. So in triangle DAE, let's see what I can use. Some people have. Can I use DAE? Some people have, because with this angle, this is my perpendicular and this is my hypotenuse. Okay, so I can use sine 32 degree 24 minutes is equals to some people means AE and have means 30. I hope you're clear with this. Now we need to calculate how much is sine 32 degree 24 minutes. So for that, please go at the back of your book, and then there they will see. Please go at the back of your book. Please go to sine table. Okay, natural sines. It is in natural sines. It is in page number 451. Please see the value of sine 32 degree. So this first column is for degrees. So see degrees first. 32 degree 24 minutes. So 32 degree 24 minute is 0.5358. 0.5358. I hope you have seen that value. 0.5358 is the value for sine 32 degree 24 minutes, which is equals to AE by 30. So which is equals to AE by 30. So hence, what is the value for AE? AE will be 0.5358 into 30 degree, sorry, into 30. So please multiply this two. I've already done the multiplication out here. You will be getting this as 5358. You will be getting a 16.074. So AE is how much? 16.074 meter. Okay, this value will be given in the question. This value will be given in the exam also. The sine, this value will be given to you. Okay, sine table, cos table, tan table, log table will be given to us. Okay, so from triangle DAE we got the value for AE, which is equals to 16.074, and now we need to find the value for BE. So in this triangle, in right angle triangle EBC, which formula I can use? Turn permanently black, not applicable. Some people have, not applicable. Curly brown hair, so this is applicable. So I have to use cos 32 degree 24 minutes, cos 32 degree 24 minutes, curly brown hair. So BE by hair, hair means 30. So please, in the similar way, please find the value for cos 32 24 minutes, 32 degree 24 minutes. The value you will get is 0.8443. 0.8443 again into 30 will be BE. So in this way you'll get the value for BE as 25.392. BE you'll get it as 25.392 meter. So yes, we got the value of AE and we got the value for EB also. We got the value for AE, we got the value for EB also. Therefore, can I find the total width of the road? Yes, I can find. So therefore, the total width of the road is given by AB. AB equals to AE plus EB. So what is the value for AE? 16.074 plus BE 25.329. So if you add this two, you will be getting 41.403 meter. So this is the width of the road. You will be getting 41.403 meter. So please pause the video and note down till here. All right, we'll keep this much for today. Your today's homework will be to do question number 13 and question number 12. Please understand and do, okay, and complete all this by tomorrow. And in the next class we'll be starting, that is tomorrow is the live class, right? So tomorrow we'll be continuing with mensuration. Okay, thank you, and do this, boys.